Okay, this is Physical Science with Mr. Egressy. Let me adjust the camera just a little bit. Go over a couple things real quick, and then we'll do that example from 9.6 in the book on page 221. So just a little bit of a review. We've got speed is equal to distance over time. That was the first thing that we covered. One thing that's on here is not velocity. Velocity is just a speed, but it has a direction, so it's directional. The next thing we have that we went over was actually relative velocity, and that had to do with the things that are on your little cheat sheet that had to do with if they're going the same way, opposite ways, or if they're going approaching each other, going away from each other, as to whether or not we have to add those velocities for relative velocity or not. So the next thing we did was acceleration. It has to do with the change in velocity. Another way that you might see that is the change in velocity over time. Okay, just for like future classes, but for this class we're going to use this. It's just the final velocity, or the velocity at the end of the problem, minus the velocity at the beginning of the problem, and then over time. Alright, and then the one thing that we excuse me, didn't get a chance to go over was distance equals half of the acceleration times time squared. So one thing that you need to know for this is free fall. Free fall is a constant for acceleration. In other words, it is always going to be this value when you drop something. So one thing in metric terms is 9.8 meters per second squared, or 32 feet per second squared. These are the metric, and these are the English. We're very stubborn in the United States. We like to keep our English, even though metric tends to be a little easier. A lot of the metric system is based on tenths or tens, a multiple of 10. English is very weird. So anyway, let's keep on going with this problem. Alright, this is example 9.6 in the book on page 221, and maybe I'll make up another problem to do as well, but we'll have to make two different videos out of it because this is going to be pretty long. Alright, so example 9.6. A young woman is standing on a bridge overlooking a river. If she drops a rock from the bridge and it takes 1.2 seconds for it to hit the river, how many meters did the rock fall? So it wants to know meters. So we don't know what the meters are. Meters are distance, so it's actually looking for a distance in this case. So our distance formula is equal to 1/2 the acceleration multiplied by the time squared. Now here's the thing, we don't have all the ingredients, or actually we do, but we have to know some of them. We know that we don't know what the distance is in meters, and since we have that we want it in meters, we're going to be using this for the acceleration, the metric unit, and not the English unit for the meter, for the acceleration. So the acceleration is something that we have in this problem, and the time is actually given in the problem too. It says in 1.2 seconds. So we got t equals 1.2. So I wrote the formula down that I need based on the information that was given, and it might be kind of confusing because you might not have known that the acceleration for free fall was this for metric or this for the English units. So we're going to actually put that in right here, 9.8 meters per second squared. Let's move everything up. Alright, now we got to substitute the stuff in. So our distance, which is what we don't know, the meters, equals 1/2 the acceleration, 9.8 meters per second squared, times the time, which is 1.2 seconds squared. Now, when we do, you can simplify it. Half of 9.8 is going to be Actually, maybe I should write this out a different way. Here, let's do this. It might help you see how the units cancel out a little easier. Meters per second squared times 1.2 seconds squared. So you could have done it this way too, that would have been fine. Alright, half of 9.8 is going to be 4.9. If you do 0.5 times 9.8, or just divide this in half, we're going to have 4.9 meters per seconds squared times 1.2 seconds squared is going to be 1.44 seconds squared over 1. Notice how these are diagonal, so the seconds squared actually cancels out. We wanted that to happen because we don't want seconds when we're just wanting meters for our answer. So now we multiply 4.9 meters times 1.44 and we get 7.056 meters. And the question is saying how many meters did the rock fall? So our answer is going to be the rock fell. Oh, let me see. I'll bring this down. Hmm. 0.056 meters. Okay. Now, just in case you didn't see this up here, I wasn't really... Nice. Maybe we'll have to redo this again. Alright. So just in case you didn't see this up here, I rewrote this and simplified. Again, we'll go over it again right now. 1/2 times 9.8 is going to be 4.9 meters. I rewrote it so we had seconds in the denominator, like 4.9 meters per seconds squared times 1.44, which was just the 1.2 seconds squared right here. So we've got 1.44 seconds squared. These are again diagonal, so we can cancel these out. And then I multiply the 4.9 because we multiply across. 1.44 is going to be 7.056 meters. And then our answer is going to be this right here. So if you have any questions, go ahead and email me, or we can talk about it in class briefly. I'm going to try to do one more of these problems for you. Alright, thanks, bye.